A circuit is given and we have to find the value of the currents I1 and I2. I1 and I2 are the two electric currents which are generated from the electric cell of EMF E1 equal 4 volt and E2 equal 2 volt. Using Kirchhoff's voltage law, in the closed loop ABCDA, using Kirchhoff's voltage law in the closed loop ABCDA, we get, using Kirchhoff's voltage law, that is KVL, I1 into 4 minus E1 plus I1 into small r2 equal 0. In this case, the EMF of the cell, that is E1, is taken as negative, because if we travel from the terminal, we are traveling along DA. That means if we move from the point D to A, we have to cross the first negative terminal of the battery. That's why EMF of the cell, first cell, E1 becomes negative. E1 is negative, minus E1, because if we travel from the terminal D to A to cross the cell of EMF E1, we have to cross the first negative terminal of the cell, then positive terminal. That's why this EMF, that means E1, will be negative. Now we can consider that the current I1 flows from negative terminal to positive terminal inside the cell. The current I1 flows from negative terminal to positive terminal through the internal resistance of the cell of EMF E1. That's why here current I1 is flowing towards left and we are traveling from D to A. And this current I1 is flowing towards left and we are also traveling from D to A, and current I1 flows through the internal resistance towards left. That means in the same direction as that of the closed loop ABCDA. That's why the potential difference across the internal resistance, that is I1 R1, will be positive. That means I1 R1 tends to plus I1 R1, because we travel from D to A and current I1 is flowing through the internal resistance R1 in the same direction. That's why I1 R1 is positive. That's why I1 R1 is positive in the equation. If we use Kirchhoff's voltage law in the closed loop ABCDA, then potential difference across the internal resistance, that is also known as lost volt, will be positive. That means plus I1 R1. And now across the 5 ohm resistor, current I1 is flowing from A to B, and we are also traveling from A to B. The name of the loop is ABCDN and we are traveling along AB, and current I1 is also flowing through the 5 ohm resistor in the same direction. That's why the potential difference across 5 ohm resistor, that is I1 into 5, will be plus I1 5. That means potential difference across the 5 ohm resistor in the closed loop ABCDA will be positive. That's why you have to write plus I1 into 5. Potential difference across the 5 ohm resistor in the closed loop ABCDA will be positive, because we are traveling along AB, and current I1 is also flowing in the same direction. Now EMF of the cell, first cell, is E1, and that E1 is negative. E1 is negative. In the closed loop ABCDA, the EMF E1, which is equal to 4 volt, is assumed as negative, because we travel from D to A, and to cross the cell E1, from D to A, we have to cross the first negative terminal of the cell. That's why this EMF E1 will be negative. If we repeat the explanation again, in the closed loop ABCDA, we have to travel from the point D to A, and we are traveling along DA. That means we are traveling from D to A, and to cross the cell of EMF E1, we have to cross the negative terminal of the cell first. This negative terminal have to be crossed. We have to cross this negative terminal, then positive terminal of the cell. That's why this EMF E1 will be negative. E1 tends to minus E1 in the equation. We get 5I1 plus 6I1 plus I2 plus 4I1 minus E1 plus I1 R1 is equal 0. Using Kirchhoff's voltage law in the closed loop ABCDA, we get 5I1 plus 6I1 plus 6I2 plus 4I1 minus 4, putting the value of E1 3I1 equal 0. If we simplify, then we get 18I1 plus 6I2 equal 4, or 9I1 plus 3I2 equal 2. 9I1 plus 3I2 equal 2. That is equation 1. We get 9I1 plus 3I2, which will be equal to 2, using KVL or Kirchhoff's voltage law in the closed loop ABCDA. Again, we can use Kirchhoff's voltage law in the closed loop FBCGF. Using Kirchhoff's voltage law in the closed loop FBCGF. In the last loop, we have used KVL in the closed loop ABCDA. Now, if we use Kirchhoff's voltage law in the closed loop FBCGF, I2 is the current which is generated from the positive terminal, and we have to give the name, we have to take the closed path in the same direction of I2. That means using Kirchhoff's voltage law in the closed loop FBCGF, we get 5I2 plus 6I1 plus I2 plus I2 plus 4. Here we are traveling along FB, and the current I2 is also flowing in the same direction across the 5 ohm resistor in the closed loop FBCGF, and that's why we can write 5I2 plus 5I2. Potential difference across the 5 ohm resistor in the closed loop FBCGF is positive, and similarly the potential difference across 6 ohm resistor in the closed loop FBCGF will be again positive. 5I2 plus 6I1 plus I2 minus 4I2, potential difference across the 4 ohm resistor in the closed loop FBCGF is minus 4I2. Then we have to consider, that is, we are traveling from C to G, and the current I2 is flowing through the 4 ohm resistor in the same direction. Current flows in the same direction of motion of the observer along CG. That's why potential difference across 4 ohm resistor will be positive, that is plus 4I2. Then minus E2, EMF of the second cell should be negative, because we are traveling from F to G, G to F, and then potential difference across the internal resistance R2 of the cell of EMF E2 will be what? Positive. Though it is written as negative, but it should be positive. We have denoted a negative pole and a positive pole of the cell of EMF E2. We are traveling from G to F, and we are traveling from G to F to cross the cell of EMF E2, and for that we have to cross the negative pole of the cell of EMF E2. That's why E2 tends to minus E2 in the closed loop FBCGF. E2 is negative. But if we consider the potential difference across the internal resistance R2, that should be plus I2 R2. Then simplifying, we get 5I2 plus 6I1 plus 6I2 plus 4I2 minus 2 plus I2 equals 0, or 6I1 plus 16I2 equal to, or 3I1 plus 8I2 equal 1. 3I1 plus 8I2 equal 1. 3I1 plus 8I2 equal 1. That is equation 2. Using Kirchhoff's voltage law in the second loop F, B, C, G, F, we get 3I1 plus 8I2 equal 1. That is equation 2. Now we have to solve equation 1 and 2 to find the values of the electric currents I1 and I2. Doing equation 1 multiplied by 8 minus equation 2 multiplied by 3, we get 72I1 plus 24I2 minus 9I1 plus 24I2 equal 16 minus 3, or 63I1 equal 13. Therefore I1 equal 13 by 63 ampere. I1 equal 13 by 63 ampere. That is one of the answer. We get I1 as equal 13 by 63 ampere. So this is the electric current. Generated from the electric cell of e.m.f. E1 which is equal to 4 volt. This is the current generated from the first electric cell of e.m.f. E1. This is the current generated from the cell of e.m.f. E1 equal 4 volt. Similarly, we can find the value of the other current I2. Putting the value of I1 which is equal to 13 by 63 ampere in equation 2, putting the value of I1 in equation 2, we get 3I1 plus 8I2 equal 1. 3I1 plus 8I2 equal 1, or 3 into 13 by 63 plus 8I2 equal 1, or 8I2 equal 1 minus 13 by 21. Therefore I2 is equal 1 by 21 ampere. By simplifying, we get I2 as equal 1 by 21 ampere. This is the electric current generated from the cell of e.m.f. E2 equal 2 volt. This is the current or electric current generated from the cell of e.m.f. E2 equal 2 volt. Now we can find the terminal voltage. V1 across the cell of e.m.f. E1. V1 equal E1 minus I1 dot R1. e.m.f. minus lost volt. Putting the values, we get that is 4 minus 13 by 63 into 3. That is 4 minus 13 by 21. And therefore V will be equal to V1 will be equal to 3.38 volt. V1 will be equal to 3.38 volt. This is the terminal voltage. Of the electric cell of e.m.f. E1 equal 4 volt. This is the terminal voltage of the cell of e.m.f. E1 equal 4 volt. Now we have to find the current flowing through the 6 ohm resistor between the 2 points B and C in the circuit. I1 plus I2. If we add the current I1 with the other current I2, we get 13 by 63 plus 1 by 21 equal, in the denominator we have 63, doing LCM, 13 plus 3 divided by 63. Therefore, I1 plus I2 is equal 16 by 63 ampere. I1 plus I2 is equal 16 by 63 ampere. This is the value of current. This is the value of current. This is the current. This is the current flowing through. This is the current flowing through 6 ohm resistor. This is the current flowing through 6 ohm resistor between the 2 points B and C in the circuit. I1 plus I2 is the current which is flowing through 6 ohm resistor towards right, and the value of I1 plus I2 is 16 by 63 ampere.